Hi everyone, today we're looking at Module 7, Lesson 19, and we're going to review the volume formula for cones and spheres, and then we're also going to look at what's called a truncated cone, or a cone that has a component missing. So our student objectives are: students use Pythagorean theorem to determine an unknown dimension of a cone or a sphere. Students know that a pyramid is a type of a cone, so it follows the same volume laws. And students can use chords to solve volume problems. And that's going to help us to revisit Pythagorean theorem as well. So the first thing I want to do is just secure my images into my notes. And you can leave these all intact in one piece. This is just going to be a quick volume computation so that we can see it and that we recognize patterns in our formulas, right? As long as we have the same area of the base and the same height, we can assume that the ratio between a cylinder and a cone is 1/3. The ratio between a rectangular prism and a pyramid is also 1/3. So the volume of that cylinder is pi r squared times height, gives us pi times 6 squared is 36 times 10 is 360 pi. 1/3 of that is 120 pi for my cone. I've got a rectangular prism, length times width times height. So I'm finding the volume is 1,440 inches cubed. Seeing that the base and the height of that pyramid is the same, I'm just going to take 1/3, which is 480 inches cubed. So I just want to take a look at this problem here. What I'm given is called a chord across the sphere. It's 20 centimeters long, and it's connected back to the center of the sphere by the two radiuses and forms a right triangle. What that means is that we can use the Pythagorean theorem to solve for the length of the radius and then plug that back into the volume formula. So my Pythagorean theorem says a squared plus b squared equals c squared. Assuming a and b are the same length because they're both the radius of the sphere, I can make that substitution and solve for the radius. I get approximately 14.14, and then I use that into my volume equation. Moving on to Module 7, Lesson 20, we're going to look at an example of that truncated cone, or the cone that's missing kind of the top or bottom piece. So our objective says students know that truncated cones and pyramids are solids, and they're obtained by removing the top portion above a plane, and it's going to be parallel to the base. So we're just going to slice the top off of that cone. Now, this volume problem is a little more complex because when I see my image, I'm missing that additional component of the cone. I'm missing that top piece. So the first thing we need to do is look at similar triangles and use the proportions between similar triangles to solve for the height of that piece. So basically what we're going to think about is finding the value for x. So I'm going to write my proportion as 10 over 8 plus x equals 4 over x. So the large triangle, bottom compared to the left side, equals the small triangle, bottom compared to the left side. I cross multiply to get 10x equals 32 plus 4x. Subtract 4x on both sides, and solve for that value by dividing by 6, and I get 5.3. Once I know the radius of that, or the height of that small cone, I can find the volume of the large cone. Remember to combine the heights. and then the volume of the small cone. And the formula for the volume of the cone is 1/3 pi r squared times height. So I'm just plugging in the information that I know. And then in order to find the volume of that truncated piece, I'm going to subtract the volume of the small cone from the volume of the large cone. So again, if you have been doing a good job applying these formulas this week, this is just an extra step or two in order to find that volume of the truncated cone, which I'm coming up with 442.8 pi inches squared.